Hello there, welcome to Excellence Class Academy, and today we'll be looking at differentiation from first principle, and we'll be solving some questions. I'll be breaking it down for you to your taste. Okay, so differentiation from first principle. Now, in differentiation from first principle, we tend to add increments to the function and then limit the function. So as you solve questions, you understand what I'm trying to say. Okay, so this is the first question we're going to solve. Y equals x. We want to find the derivative of this, the dy dx. So how do we do that? Now, the first thing you do is add a small increment. This means increment. Some people call it delta. Some people call it increment. Some people call it change. Some people call this change in y. Any of them. So this is a small increment in y. You add a small increment in y. Plus you also add a small increment in x. Okay? Now, what you do, you take this y to this side, and then it becomes change in y, or small increment in y, equals x plus small increment in x minus y. Now, recall from here that your y equals x. So meaning, see my y, I'm going to replace it with x. So it becomes small increment in y equals x plus small increment in x minus x. Now this plus x takes away this minus x. You have small increment in y equals small increment in x. Now we're going to divide both sides, or divide through by small increment in x. So it becomes small increment in y equals small increment in x over small increment in x over small increment in x. So anytime you have small increment in y over small increment in x, it becomes dy dx equals, now small increment in x divided by small increment in x gives you 1. So our dy dx, or our derivative, gives us 1. So when we differentiate x, we get 1. Okay, I hope you understand this. You can rewind the video and watch it over again to get to understand it. It's simple. It's not complicated. You just have to understand it. Okay, so this is the next question we're going to solve. Y equals x squared. We want to find the derivative of this from first principle. Now, like the previous example we did, we're going to add a small increment in y to this equals, now this is x squared. So you don't come and add a small increment in x like this. This will be wrong. This will be wrong. Very wrong. Okay, so what you're going to do here is, it becomes x plus small increment in x all squared. This is what it becomes. So it becomes y plus small increment in y equals, now open this bracket, it becomes x squared. That's when you open this bracket, it becomes x squared. Use this to multiply this, and use 2 to multiply, it becomes 2x small increment in x plus small increment in x all squared. That's when you open this bracket, it becomes this. Now, we are going to take this to this side. So it becomes small increment in y equals x squared plus 2x small increment in x plus small increment in x all squared minus y. Now, recall that y equals x squared. So this becomes small increment in y becomes x squared plus 2x small increment in x plus small increment in x all squared minus x squared. Now, this x squared takes away this minus x squared, so it becomes small increment in y equals 2x small increment in x plus small increment in x all squared. So from here, I'm going to divide through by small increment in x. So it becomes that small increment in y over small increment in x equals 2x small increment in x over small increment in x plus small increment in x all squared over small increment in x. Now, small increment in x takes away small increment in x. Now, this is still small increment in y over small increment in x. Let's hold on with this. This takes away this. You have 2x plus small increment in x. This is 2x plus small increment in x. Now, we're going to limit small increment in x as it tends to 0. So it becomes that small increment in x over small increment in y over small increment in x equals limit small increment in x as it tends to 0 in this. So like I said, this becomes dy dx. So it becomes dy dx equals, now when you want to limit small increment in x as it tends to 0, just for you to substitute anywhere I see small increment in x, substitute it with 0. So it becomes 2x plus 0. And then 2x plus 0 finally gives us 2x. So dy dx equals 2x. And this is our derivative. That's the differentiation of x squared. It gives us 2x. Now, we'll be solving this question next. Y equals root x. Okay? And we want to find the derivative or differentiate it from first principle. Now, like what I did previously, it becomes y plus small increment in y equals, this is as a function result of this. So it becomes x plus small increment in x. Okay? So take this here, it becomes small increment in y equals root x plus small increment in x minus y. Now recall that y is equal to equal to root x. And then this becomes small increment in y equals root x plus small increment in x minus root x. Now, what are we going to do next? We're going to divide through by small increment in x. So it becomes change in y equals root x plus small increment in x minus root x over small increment in x. Now, okay, we have this here. So, like I said, you divided through by small increment in x and then it becomes this. I can split this, but let's leave it like this. Now, next thing we're going to do is limit change in x as it tends to 0. So it becomes small increment in y over small increment in x equals limit change in x as it tends to 0 in root x plus small increment in x minus root x over small increment in x. Now, for you to limit something like this, meaning you substitute small increment in x into this. Now, do not do that yet. If you have watched my videos on how to limit a function, you would have noticed that you can't just limit this here. Because by the time you limit this here, you're going to get, this will be 0, this will be root x minus root x, everything here will be 0, everything here will be 0. And 0 over 0 is undefined. So you don't want that. So what are we going to do? We're going to multiply up and down, that's the numerator and the denominator, by the conjugate of the denominator. So it becomes small increment in y over small increment in x equals limit in x as it tends to 0. Then this becomes this, okay, minus this multiplied by this plus this. Okay, over small increment in x, all multiplying square root of x plus small increment in x plus plus root x. So like I said, we are multiplying the numerator and the denominator by the conjugate of the numerator. The conjugate of the numerator is all root x plus change in x plus root x. Okay, now if you notice, this is difference of two squares. It's the same thing, but one is minus, one is plus. So it becomes this, that small increment in y over small increment in x equals limit small increment in x as it tends to 0 in. Now this can be brought together as difference of two squares as this all squared minus this all squared over this remains here. Okay, I hope you get that. Difference of two squares can be simplified to this. Now the square takes away the square root here, it becomes small increment in y over small increment in x equals limit this as it tends to 0. Now the square takes away this square root, it becomes x plus change in x. The square takes away this minus x over small increment in x over root x plus change in x plus root x. We're going to continue from here. So small increment in y over small increment in x will be equal to limit change in x as it tends to 0. Now, this plus x takes away this minus x, so you're going to be having small increment in x over small increment in x into root x plus small increment in x plus root x. Okay? Now, this takes away this, so you're going to have small increment in y over small increment in x equals limit x as change in x as it tends to 0. And this takes away this, so you have 1 over, this is going to be root x plus change in x plus root x. Okay, now finally we're going to limit change in x as it tends to 0 in this. So this now becomes dy dx becomes 1 over, this becomes root x plus 0. That means I'm substituting change in, anywhere I see change in x, I'm substituting it for 0 plus root x. And then this becomes dy dx equals, this is 1 over, this is going to be root x plus root x, which finally gives us 1 over root x plus root x is 2 root x, and that will be our answer. Wow, wow, that was hell of a wow, but that will be our answer though. It's simple, it's simple, simple, simple. Okay, so that will be all for today. In my next video, I'll be solving more questions on differentiation from first principle. Thank you.